Welcome to the deep dive. Today we're taking a look under the hood of a very specific piece of hardware.
Very specific.
It used to be the absolute backbone of large shared television systems. We're talking about the discontinued Thor Broadcast H-RF-AMP-30.
Right, and our mission here is basically to translate its dense technical specs into the real-world problem it was built to solve.
And this thing was critical for huge systems.
Oh, absolutely. Think massive apartment complexes, MDUs, or multi-dwelling units, and these complex broadband CATV networks.
We're really talking about the main signal artery for potentially hundreds, maybe thousands of users.
Precisely. This unit was built for what's called trunk distribution. That means it's designed for systems where you have to do what engineers call cascading.
Chaining amplifiers together.
Exactly, chaining them one after another over long distances. And in that situation, noise and distortion, they don't just add up, they multiply. So to survive that, the HRF-AMP-30 had to deliver two things: a massive amount of power and almost zero distortion. And just as a side note, if you're looking for this today, you'd be looking at its replacement, the HRF-AMP-40.
Okay, let's get into the raw power then. The specified gain is a pretty hefty 30 dB.
Sometimes even up to 32 dB, yeah.
And the output level is huge, 60 dBmV. My first question is, if you're pushing a signal that hard across, 158 channels, isn't there a massive risk of just terrible distortion?
That is the core engineering trade-off, isn't it? You absolutely need that 30 dB of gain to overcome all the signal loss in the cables and maintain a stellar carrier-to-noise ratio.
Which gives you the clear picture.
Which is essential for that crystal clear picture quality. What's fascinating here is how they manage the distortion. That 60 dBmV output is a staggering amount of power, and they achieved it cleanly using a state-of-the-art hybrid push-pull technology.
And what exactly does push-pull do for the signal?
Well, it's a very clever circuit design. It specifically cancels out what we call even-order harmonics, and those are really the nastiest types of distortion in a multi-channel video system. By getting rid of those, they could drive the signal much harder, hit that high output level, and keep the audio-video quality pristine.
So beyond just raw power, there's a serious quality control aspect. When you have 158 channels running through one box, the consistency has to be flawless. I'm seeing the sources mention a tight plus or minus 0.5 dB flatness across the entire band.
And achieving that flatness across a 1,000 megahertz spectrum is incredibly difficult.
I can imagine.
Think of it this way. That tiny tolerance guarantees that every single channel gets a perfectly level ride. If that response wasn't flat, some channels would be too weak, others too strong, and the picture would just fall apart. You couple that with a low noise figure like the 5 dB on this unit, and you're ensuring the amp itself isn't adding any noticeable defects.
But maintaining that perfect signal isn't easy, right? Especially when you start chaining these units together in a huge building. How does a network manager actually balance the system in the field?
That's where the management features really shine. You see, higher frequencies lose energy faster over distance than lower frequencies. Engineers call this tilt.
Right.
So this unit had adjustable gain and slope controls specifically to compensate for that and balance the signal. On top of that, for diagnostics, it has these easy access, low loss, NAC up to 20 dB test points.
So a technician can plug in without taking the whole network down.
Exactly. They can check the signal without disrupting service at all. It makes setup and monitoring so much simpler.
And there's a physical security element, too. The specs mention a shielded enclosure with over 95 dBs of RFI shielding.
That RFI radio frequency interference shielding is vital. A 95 dB rating means it's extremely good at keeping the strong signal inside from leaking out and causing interference, and just as important, it keeps external signals out.
Like Wi-Fi or radio broadcasts.
You got it. It stops them from getting in and contaminating the CATV channels. You add in the built-in lightning and surge protection, and you have a really robust piece of infrastructure. And of course, it uses all the industry standards, 75 ohm impedance, F-type connectors, and it only sips about 10 watts of power.
So when you put it all together, what does it all mean? These details, the push-pull, the flatness, the controls, it really defines the difference between a consumer-grade mess and a true enterprise-grade delivery system.
It does. This amplifier was engineered to manage distance, interference, and power across a huge number of channels without any degradation. And, if we connect this to the bigger picture for a final thought, just consider the silent, invisible engineering guarantee being made.
A guarantee to who?
To every single tenant in a massive building. It's a promise that they will receive the exact same signal quality as the person living 5 feet from the amplifier, even if their own apartment is 500 feet down the line. That relentless pursuit of consistency, that's the real unsung story of devices like this.